Hi, good morning. Normally we read Mystery of History, but today we're going to be reading from Science in the Age of Reason because Dr. Weil puts these scientists in order of how they came about during history. So we're going to see what type of science was going on during the same time period. We had been reading about the 13 colonies, and we had been reading about Jonathan Edwards and George Whitefield and the Great Awakening. Who else did we read about? We read about some composers, didn't we?
Yes.
We read about Handel and Bach. And where were they? Forget where they were. I think Germany. And where was Handel? Do you remember? Also in Germany. Okay, so Handel and Bach in Germany. At the same time, the 13 colonies were being established. At the same time, the Great Awakening was going on through Jonathan Edwards and George Whitefield. And now we have around a little bit smidge later, in 1740s, we're going to go back to the 1730s, I think, with Antoine Laurent de Lavoisier. What type of name you think that is? French, for sure. Faux show. Okay, he was born into a very wealthy French family. So we're on page 125, sorry, in the Science in the Age of Reason. We had picked back up on this book after a while. We decided to include it into our history. So it took us a while to catch up our history to our science. So now we've caught up. We're going to do them together so that we can see what was going on in history and science both. So during the same time, okay, so Lavoisier's father was an attorney. That means a lawyer. And he earned a degree in law. Lavoisier, Antoine, he earned a degree in law, but he never practiced law. He became fascinated with natural philosophy. To produce some income, he did purchase part ownership in a company that collected taxes for the government. And he ended up marrying the daughter of one of the owners, and her name was Marianne Perriette. Perriette Poles. We'll call her Marianne. His wife was a great help to him in his studies of natural philosophy. First, she knew English much better than he did, so when he wanted to read works that were in English, she would translate them for him. And she also assisted him with his experiments and made sketches of his scientific instruments so he could better communicate his experiments with other philosophers, natural philosophers. And natural philosophers means a scientist in this book, or during this time. So being able to draw and make pictures helps people who are reading what he's written to understand what he's writing better. While studying many things, including the problems associated with lighting city streets at night, the investigations for which he's most famous center on combustion. Combustion is the process of burning. At the time, natural philosophers thought that things like paper, wax, and wood burned because they contained a substance called phlogiston. I have never heard of phlogiston. As the burning occurred, this phlogiston would be released into the air. This is what they thought. Obviously, this was not what was happening. However, air could only hold up to a certain amount of this phlogiston. I feel like I keep saying it like phlogiston because it's not really real. So if the combustion happened in a closed container, it would eventually stop because air would become completely full of this phlogiston. Joseph Priestley, Henry Cavendish, and most other natural philosophers thought this was the best explanation for combustion. But Lavoisier's experiments helped him to understand that they were completely wrong. For example, he burned two chemicals called phosphorus and sulfur, and that showed that rather than losing weight, like you would expect if phlogiston was being released, So if something is burning and it's releasing phlogiston, then it's going to lose weight because it's giving something off. It's like giving something away. But instead they actually gained weight. And this indicated to Lavoisier that something was being added from the combustion process. Excuse me. Later he met with Joseph Priestley, and he described the gas that he had pulled out of the air. What do you think that gas is? Hold on, let me give you another clue. He told Lavoisier that this gas was really good to breathe. What do you think it is?
Oxygen.
Yeah, oxygen. And it promoted fire. This led Lavoisier to conclude that combustion had nothing to do with releasing this phlogiston. Instead, he said that combustion was the result of combining a fuel, meaning like wood or paper, with a gas that was found in the air. He named that gas oxygen, and the name stuck. So now we know that combustion is the process where chemicals in a fuel are combined with oxygen. That process releases a lot of energy, which we detect mostly in the form of heat and light. A little quieter on the Legos, please. We're playing with Legos today. Again, because Priestley's work was necessary for Lavoisier to figure this out, most historians give them both credit for discovering oxygen. To get an idea of how important oxygen is for combustion, what they want us to do, which we're not going to do right this minute, but we'll describe the experiment, is to light a candle and, let's see.
Oh, we've done this before.
No, not that one. A different one. Let's see. It says, hold the flame over a bottle with hydrogen peroxide in it. It looks like you're mixing the yeast. It looks like you're mixing yeast with hydrogen peroxide. Yes. It says hydrogen peroxide is unstable. That means it tends to break down very quickly into water and oxygen. This happens naturally, but usually slowly. You can keep hydrogen peroxide for a while, as long as it's in a dark bottle. Light speeds up the process. But when you add yeast to hydrogen peroxide breaks down a lot more quickly into hydrogen and oxygen. Into water and oxygen. Because yeast speeds up the decomposition. When this happens, we call it a catalyst. The yeast is the catalyst because it kind of prompts the hydrogen peroxide to break down more quickly. So, what happens if hydrogen peroxide is breaking down into water and oxygen quickly, and you hold a candle over the hydrogen peroxide that's breaking down, what's going to happen to the candle? To the flame. You're holding a candle with a flame over, you have to be careful, but you're holding it over hydrogen peroxide that's quickly breaking down into water and oxygen.
It's going to fuel the fire.
That's right. It's going to fuel the fire. The flame is going to get a lot brighter because there's a lot of oxygen spewing up out of that hydrogen peroxide. I'm trying to think if we have a candle we could do that with. We do, actually. We'll do it in just a minute. Let's see.
Should we videotape that one?
We could. When the flame and the wick were put above the bottle, they're in the presence of a lot more oxygen, and this allowed for a lot more combustion, which makes a brighter and hotter flame. Lavoisier reasoned that since combustion needs oxygen, perhaps that same gas is used by people and animals, which is why we breathe. It was also known at that time that people and many animals had some internal heat source because their bodies were usually warmer than the air around them. He thought that perhaps something similar to combustion was happening in people. to test this idea, he did detailed experiments comparing gases and heat that were involved in combustion to the gases and heat that were used in people and mice as they were breathing. He found many similarities, and he finally declared that there must be slow combustion going on in people and animals. And this combustion is why people and animals need to breathe, and why people are warmer than the air around them. Turns out he was right about that as well. It might be hard for you to believe, but combustion is the way that you get energy from your food. After your body digests the food that you eat, many of the chemicals in the food get burned in your body, producing the heat that warms your body and gives you the energy you need to live. Now, don't get the idea that there are little fires going on in your body. Because of Lavoisier, we know that combustion is a chemical reaction.
Because if we were drinking water, it would probably put out those fires.
That's a good idea. If we were drinking water, it would probably put out a fire if it was in there. A chemical reaction, which is a fuel combined with oxygen to produce energy. The fuel would be food combined with oxygen to produce energy in our body. So your body does this in such a well-designed fashion that it never produces fire. Instead, it just produces a gentle release of energy that your body can use without ever being harmed. So it's very interesting because it's so well designed that a fire is never produced. So how do you think that happens? Yes, that's because there was a designer of the body. It didn't just happen accidentally. Oops, a perfectly designed combustion process that never results in a fire, only energy. No, a designer actually did that, and his name is God. All right, Cruz, can you tell me what is combustion?
Combustion.
I have to look back.
So combustion it's when you take two things and convert it into energy.
Close. Pretty much. It's the process of burning. In our body, that process produces energy. Caleb, what does combustion have to do with our bodies?
It like burns up food so it can come out.
So we can get, what does food give us to live? Not only
Energy.
nutrients, but energy, yes. All right, we're going to go do our experiment now. Make sure that if you decide to do an experiment, you actually look at the instructions on page 126 and you have an adult with you. Do not just do this experiment without any supervision or instructions. That can result in catastrophe. Have a good day.
Yes.
All right, go
and
ahead.
Make sure you get the book.
All right, bye-bye.